camera, we're going over the final project here. We're talking about branching. So to fulfill this requirement, it has to have an if statement in there that does something. That's all that. It has to have an if statement in there. This is SPA. It has to have an if-then statement. It doesn't have to actually be an if. Yeah. I mean, you could say if-then. It has to have an if statement in it. Looping. What does looping mean? Yeah, it's got to have a for loop or a while loop in it somewhere. It's got to do something repeatedly. So, in the past, what I've done is some people say, well, I don't have anywhere I can put a loop in my code because I just want my code to do this one thing, and it doesn't involve looping. Well, I do still want you to include looping in your program. And one easy way to include looping in your program is to make it so that your if you have a calculate field or a calculate value in your code, okay, that instead of doing it using the calculate field tool, you do a loop and you do what we did last week, and you loop through every record and you calculate a new field using the method that we talked about last week. So that's a way that, you know, if your code doesn't involve any looping, you can still do because almost everybody's going to be calculating a new field for some reason. So your problem has to have some looping in it, and that's one way to get it in there, so that you can demonstrate that you can write your own loop into a program and get it to work. Okay? Then it has to run at least 2 different GIS tools. In other words, it has to call a tool from the toolbox, like ArcPy Union, ArcPy Intersect, ArcPy Select. You need 2 tools. Now, in the past, people have used many more than just 2, but it has to include at least 2. And all of these are like checkboxes. You either get them or you won't get them. Okay? All right, undergraduates must turn in a short 2-paragraph description of what their tool does. So you need to tell me what your tool does and why it does it. But it's going to just be a short description of that. It's not going to be a long description. Okay? Graduate students are responsible for writing up a paper along with their tool. That's the wrong there. The paper must describe the need, using some background information, for such a tool, and examples of the tool executed on some data. So the undergraduates don't actually have to execute it. It might be helpful when you turn it in to say, this is the data I was testing with. In fact, that would be very useful. But the graduate students have to do that. So some examples of things in the past, I've had people turn in a project that calculated, that did kind of like a multiple ring buffer analysis, and created basically how many, I think it was turtle nesting sites are within 5, 10, 15, 20 miles from roads. I guess I should probably go back and look at some of the other examples, but it can be fairly simple. And it's basically, I'm looking for like a similar effort as to one of these lab assignments. but you are basically coming up with the problem. It doesn't necessarily need to have lots of different GIS data sets as inputs. You could just have one or two data sets as input. But I think in most cases you'll have some GIS data as input, almost always. And as output, it doesn't always have to be GIS data. It could be more of a report style information. In other words, it could just be a table, but it could be something, could be another GIS layer. If you took the Intro to GIS class, feel free to use a lab that you did in that class and basically automate it, basically create a tool that completes that analysis by writing it. And you may have to, as I said, put in some looping as a calculate field. Now, if you're looking for branching, go back and look at the lab. Try thinking about your problem as allowing the user to do two different, to analyze it two different ways. Like maybe they want the result in, if your tool is going to produce the amount of area for something, let them choose whether or not it's going to be in feet or meters, and then just multiply the values differently for this, if this is this case, or versus if it's this case, okay? There's all sorts of ways to work in an if-then statement in there, even if you don't think that it needs to be there. Okay? Any constant that you can think of, you can think about putting it in different units. All right? Next week, I'll come prepared with a few more examples of previous papers. It's been 2 years since this class was taught, so I can't think off the top of my head as well. But did I answer a lot of questions? Some questions? Okay. I never have people turn in anything longer than 10 pages for the graduate students. Like it's more like I should probably change this to say like between 5 and 10 pages. Right? So, yep. Yeah, and it's very useful. If you can think of, if you're formulating something for your thesis, for those of you that are master students, I know there's 3 up here. It's useful to use that, or at least draw from those experiences. Okay. So today we're not really gonna. Well, I'm about to say we're not really going to do anything new, but we are going to do stuff new. It's just now we're going to talk about writing out geometries rather than just reading them in. And so, to start, what I'd like to do is to just practice writing points, lines, and polygons into a file, into a feature class, a new GIS data set. So I do this fairly often. There are actually tools to do lots of these. Well, what I'm going to demonstrate is basically just making rows and columns of the GIS data, like a bunch of points in a fishnet. There are actually tools for doing this nowadays, but surprisingly, even 10 years ago, most GIS systems didn't have the ability to have a tool to just make tessellations really easily. We'll practice just making tessellations, and then you could really do any sort of feature that you wanted to do. I should have put, and I will add this here in a second, but I'm just going to Google ArcPy, write geometries, and then I'm going to write ArcMap, because sometimes it'll show you the ArcGIS Pro help, which is, lots of times it's exact same in the code, but it's not always the exact same. So If you ever search into help, by the way, and this says Arc Pro instead of Arc Map, or it just says Pro, then the help is for ArcGIS Pro. And I would say 99% of the time, the text is going to be exactly the same, but every once in a while, it's a little bit different. Okay? But ESRI created both products, so they're both similar. But they should actually have like these kind of look deceptive, right? These look like you could press this button and it would just take you to the ArcGIS Pro version of the exact same topic, but that's not what it does. That would be nice. They should have that ability so that it would help people that are trying to switch over. All right. So we're going to talk about writing geometries today. You can actually change the help version here. I know on our computers up here, I think we're running 10.5 or I don't know, but those are more subtle, little teeny differences, and almost all the time those are the same. Okay, so in order to write geometries, one of the things that we have to have is a new shapefile to write to, or a new, shouldn't say shapefile, a new feature class. Okay, the feature class is the general term for the thing that a shapefile is, or an item in the file geodatabase. It's a data layer, a GIS data layer. So that's what ArcGIS calls it. Okay, so you can see how here in this code, this first line of code here that says import ArcPy is opening up ArcPy. The second line is just getting a reference to a location, and the third is opening it up using an insert cursor. We talked last week about a cursor, and there are three types: search cursor, update cursor, and we demonstrated those two last week, and the insert cursor. So there's a search and the update, which we talked about last week. The insert is the one we're going to talk about today. Insert cursor allows us to put new rows into the database. In other words, create a new feature. Insert cursor is the one that we're going to deal with the most today. And what it does is allows us to create new features. Is another way to say that. Okay. So there's a few concepts that we have to remember. We did talk about these a little bit last week, but now we'll make them a little more solid in our brains here. So the next line of code, what it does is it creates a new array, because everything that is not a point is actually just a group of points. So these rows are groups of points. So this is just a line that's made up of 2 points. So we're adding that little line segment into this data set, and we're inserting it in as a row. Now, you might be saying, what about the other attributes? Don't roads have other attributes like speed limit and things like that? Well, this example doesn't show any of that. So I'll show that when we get into an example here. But what if we wanted to put this information into a brand new data set? If we wanted to put this information in a brand new data set, how do we create a brand new data set in code? Well, the easiest way to do it is actually using ArcGIS's, there's a toolbox for creating a brand new data set. A tool, not a toolbox, a tool for creating a brand new data set. So the workflow is if you want to write your information into a brand new, fresh geometry, fresh feature class, you have to create that feature class using the create feature class tool. So we'll show that here. It's been raining off and on and off all day, hasn't it? Is it supposed to get is it supposed to get like tornadoes and stuff like that or no? A tornado. Wow. All right, so under data management, There's one called I thought there was one called create. Let's look for search. Windows, search. I've found that ESRI almost always calls it what I don't think it should be called. Make feature layer, that's not right. Create feature class, yep, that's it. Create feature class, that's what we want. Oh boy. Really small. So it's under Data Management Tools Feature Class, Create Feature Class. That's where it is. So I'm going to double click on it. All right. Now, you'll notice here that we have a feature class location and a feature class name. And you feed those two, it's separate. So when we go to write this up in Python, you'll first create your feature, you first specify a location, which is kind of like a workspace. And then you'll put the name of the data set you want to create in that workspace. Now, geometry type is what you think it is. It's the point, line, or polygon that you want to put there. There's also multi-point, that's one option. So there's point, multi-point, polygon, polyline, and multi-patch. Multi-patch isn't used that much. So we all know what points are. Multi-points means that in a single line there's multiple points stored. Polygon and polyline, those are the ones that are used the most. Okay? So you have that choice. So you either make the choice right when you create it. And then this template feature class is interesting. And it's actually useful, more useful than you might think. The template feature class, it says, the feature class uses as a template to define the attribute schema of the feature class. What's the attribute schema? Do you know what that means? I might have even used that term earlier in the course, but I may not have.
Like the way the attributes are set up?
Yep, it's the way the attributes are set up. It's the names of the attributes and all of the restrictions that the attributes have. So what data type they are, what length they are, what the precision is. And so if you have an existing data set, and sometimes it's easiest to do this, to set up an existing data set that's empty, that's going to have all of the rows and columns that you want, and then just every time you want to create a new one, you just refer to that template, and that way you don't have to add all the rows and columns that you normally would. If you find yourself writing code that creates a bunch of rows and columns and they're always the same, it might be easiest to just create a template feature class. But like if you have a tool that's going to do that as part of the process, create a template feature class. All right. The coordinate system can also be defined. You can either reference a PRJ file, or you can actually reference a data set that already has a projection associated with it. So you can reference a data set or a projection. And if you reference a data set, it'll just use that. So if your data set's in Mississippi State Plain, then it will put it in Mississippi State Plain. So if I choose this, then it's going to actually write that. Let's look at the help, because then you can see using Python example what you would put. Yeah. So you could use describe to get a spatial reference. So I get the spatial reference of this existing data set dot spatial reference. Alright, so how I could create a spatial reference using an existing data set. By entering a PRJ file, by referencing a feature class, by defining a spatial reference object. That's probably the hardest one. Well, okay, this one's just referencing a a PRJ file, but what I meant would be the hardest one is if you were actually trying to create your own custom spatial reference, where you had to define the shape of the Earth and what units you were using and that sort of thing. All right. So let's practice implementing this. We're going to create a new. What do you call it? A brand new data set. And our brand new data set is going to have, our brand new data set's going to be, we're going to start off with a point feature data set, and then we're going to demonstrate polyline and polygon. So I'm going to go into Python, or IDLE. Create a new file. I'm going to say import ArcPy, and then I'm going to create a new data set, a new feature data set. So I'm going to copy from the help. I'm going to copy this line right here: create feature class management. I know there's other things, but we'll type those in there anyway. All right, so our path is going to be an output location. I'm going to put outPath equal to, I like to do the R, type R, and then type the name of the path that I'm going to save it to. I'll put this in C/temp. And then SPA lab, I think, is the one I've been working in for the last few weeks. /SPA lab. So that's the path. That's where it's going to put this data. I'm going to go ahead and create a new, no, I can't do that on ArcGIS. I'm going to create a new, oh, there, our catalog. Inside that path, I'm going to create a new geodatabase. That's the word I'm looking for, sorry. I'm going to create a new geodatabase in that path in order to, because I'm going to write into that geodatabase. You don't have to do that if you want to. You can make it a shapefile. Actually, that's taking too long. I'm just going to write out_name equals points.shp. Okay, this actually matters right here. Okay, if you type in, if you don't put that .shp on there, does anybody know what file, what data format it's going to write it in? The default, okay. Yeah, what is the default? So if it's a, these are vector or raster data sets. Points, lines, and polygons. Vector data sets, exactly. Okay. So there are basically three main types of vector data sets that are in use by ArcGIS today. Okay. There's been a few others in the past, but there are three principal types. And the way you specify this depends on which type it will be. If your path is to a file geodatabase, in other words, if it ends in .gdb, then don't put shape on there. It won't even work. Okay? It'll say that path is invalid error. Remember that type of error? It'll say that. Because that's a file geodatabase. It's writing to a file geodatabase. Right? So that's one type, file geodatabase. If this points to a folder, which ours does point to a folder, if you put .shp, it makes it a shapefile. And the shapefile is actually the newer of the last two that we're talking about here. The shapefile is a format that was invented when ArcView was first created. The last format is called a coverage, an ArcGIS coverage. And ArcGIS coverages aren't used as often anymore, but if you leave off this .shp, That's what it's going to create. It's going to create an ARC, what's called an ARC info coverage. What's that?
I thought they were already doing everything in shape, but the default output, and I don't know where it's.
Yeah, so if you leave off .shp, it'll save it as a coverage. If you put it into a geodatabase and you include .shp, it won't work. You don't put shp. And it'll be a file geodatabase. So there's no ways to specify, I want a shapefile, I want a coverage. It's just based on where you're trying to save it and the extension you're using. So the geometry type now, that needs to either be point, line, polygon. It's one of those choices. So we're going to start with point. Let's make sure that that's the right syntax. This one says polygon, but we're going to do point first. All right. Okay. Just going to create that. And that's geometry type. Now, if we leave that be just like that, all the rest of these parameters, let's make sure I'm right, but all the rest of these parameters are optional. Optional, optional, optional. They're all optional. Okay? So I'm going to try running this just as it stands. And we should get a new point shape file with nothing in it in this folder. Whichever folder you've specified. You might have specified a different folder. So I'm going to hit run and hit OK. Got to save it somewhere. I am going to save this as example in the SPA folder. ctemp. Let me make sure that I've synced my SPA folder first. And it isn't ctemp SPA. Okay, ctemp file save as ctemp SPA week 9, and this will be example 1. All right, it shouldn't produce any, I didn't ask it to print anything. So as soon as it's done, it's just going to print out those triple carets again. That's actually, those aren't carets, those are greater than signs. Did it finish? No, it's still working on it. I don't know why that's taking so long. Oh, there, it finished. Okay, so now that's done. And if I go into ArcGIS, I'm going to look at it in our catalog. Yep. That is catalog. ctemp SPA lab. Oops. SPA lab. And then now I've got that points.shape. See, it's right there. I can add it into ArcGIS. Notice that it gives me this error. Unknown spatial reference. We didn't assign it a spatial reference, so that's what we should expect. Okay? And if we look at the attribute table, it's empty. There's absolutely nothing in it. Now, ArcGIS actually requires that there be another field besides the shape and the unique identifier. For some reason, it can't wrap around it. It just doesn't. It doesn't even work if you don't have another field. So, so that's why I added that ID field, even though I didn't tell it to. So if you don't give it any fields to add, it will put that ID field in there. So unless you give it a template, it'll be there, and then when you try to add fields, it'll still be there. So if you don't want it, you have to delete it out of there. All right. I'm going to close it. I'm going to actually delete it. I'll go back to there. Anybody have trouble getting that to work? What's that? Yeah, when it runs, it doesn't really tell you that it finished. So you have to check in that folder. Did it give you an error? If you try writing it again, it might give you an error because you didn't overwrite the output. So what happened?
It just made it
All right.
I guess.
But it did work now. So you're trying to fit in that. Yeah, that worked. Did yours work on it?
It's just a mission of those computers to make me look stupid in front of your brain.
Yeah, that's it right there. No, it's not underneath the box. These are all the things that are, those are the same level as that. They're all in that. Right, I did delete it because I'm gonna. Alternatively, you could import ArcPy. No, actually, you could just do ArcPy.env. What is it called? Overwrite output equals true. What's that? Thank you. So now you don't have to delete it if you don't want to. All right, so now we're going to practice shoving things into this. Shoving things into this shapefile. Okay. Actually, I'm going to put this really quick just to demonstrate what this does. You don't have to follow along with me putting in a different file. Oh, I forgot to put that second thing on there. All right, so what's that doing? I showed it, but logically, what's going on here? Yeah, it's two counters, one nested inside of the other, right? So I'm actually going to get, inside there, I'm going to get every single combination of I and J. I'm going to get, 0, 1, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, all the way out to 10. And I'm also going to get every combination of the other direction. I'm going to get everything 0 to 10, 0 to 10. So what I'm going to do here is maybe is to basically create all the numbers from 0 to 10 and numbers from 0 to 10 simultaneously. And the purpose for this is that I'm going to create points at 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and then at 1, 1, 1, 0, all the way down. So I'm going to get an evenly spaced grid of points. It's pretty straightforward, but that's what I'm going to do. All right, so I'm going to close this out and put it back into this file. So I've created my feature class, and now I do have to put in a few lines of code up here to do the to do the insert cursor. So let's go look at that code. I still have it up here, right? So I've actually created the data set, but now I need to do the insert cursor. Okay. And this example is actually better. So if you're just dealing with points, your code's going to look like this. You're going to say cursor equals, and this actually could be any variable name. Huh. And when did they go dark?
I have no idea. That's what I'm.
Yeah, that's a good question.
I'll text, Megan.
Hold on here. Contacts. It says cannot reach them. Yeah, my guess is that it died. I'm just going to repeat this next stuff if they come back, but it looks like they're trying to get help from iTech. So I have that line of code from writing geometries right there. I'll just put this in. So this says cursor equals arcpy.da, remember that? And insert cursor. This is the feature class. Our feature class, we need to put the path to the entire feature class. So we actually don't have that yet. We could do something like this. FC equals outpath plus out main. Okay. Put an R in front of that, otherwise. Okay. Make sure your slash goes this way too. It actually matters. So this is basically saying the outpath plus the name is going to equal feature class. Can you just write that? No, because this is a string, and this is like we need to create a string. We can't just write outpath slash because it wouldn't know to convert this into a string. We could put a slash right there, actually. That is one option. Like from the very beginning, I'm pretty sure it would still work if we did this. And then that, maybe. All right. See if we can get these guys back.
So Megan told me they lost internet and they were living on my side, and now they have power and they have power and everything, but they lost connectivity. So you might want to try calling them.
Yeah, I'm trying to call them again. It just says can't. It cannot reach.
Oh, we have to fix. Can you get I can call Candace because she said that their internet is. I told them that their internet is highly competitive, so we have to fix it here and here, and the whole campus bears out.
Okay.
Can be on the TV if they have a light.
What we're doing here. Well, that's unusual, right?
Yeah.
What's the name of the secretary 2 secretaries ago? Shannon.
Jennifer?
Well, that's 3 secretaries ago, right?
Oh, really? I thought it was 2. I don't know what.
You're right. I have it under Jennifer, not Shannon. I had it under Shannon, but then I kept calling her by accident. Yes, Candace, this is George. Evidently, the coast's internet is out. Is that? I was trying to teach a class, and their iTech dropped. And the iTech person called me and said that the iTech up here has to fix it. The iTech person from the coast. Does that make any sense or no? I don't know what I'm talking about, but I guess the iTech people there claim that Hattiesburg does something. Yeah. Should I call Kevin?
I always call Candace and I'm like,
Or-
explain what's going on. With all my theories.
It could just be something they already know about, though, right?
That I have a lot of theories about, I like to say stuff.
Yeah, the IVN depends on the internet, and that just died. And the students are calling me and saying that the internet's out. Their internet's out too. So. Okay, thanks a lot, Candace. Bye. All right. All right. Well, I'll just continue on since there's nothing I can do, and it's going to be on the video. So, Candace is trying to get iTech to help. All right. So these are the fields that you want to update. And remember that we insert these just like a list. So I'm gonna run this once, just doing this. But right after that, we could update the ID too. Remember, ID was a name. So that field is going to be on there. We could update the ID too. But for now, we're just going to do this. Now, if it's a point or a polyline, just leave off x, y. Sorry, polygon or polyline. Polygon or polyline, leave off x, y. If it's a point, though, include x, y on there. All right. So the next thing we want to do is loop through and add all these points, because this code is just going to add 1 point. But what we want to do is insert. Instead of, well, we'll just leave the print on there, but we're going to insert our, in a row, we're going to insert a new row, and it's going to be xy. Instead of xy, it's going to be I, comma, j. Actually, let's do, okay, so if you look at this syntax, what's xy here? It is essentially, but it's exactly a tuple. Yep, it's a tuple. So we have to feed it in as a tuple. Good. Hey, how's it going? We got you back. All right, we didn't get too far, so I'll just review real quick. So, how did y'all have to fix the problem?
The whole entire network for the whole campus was down. They fixed it, I guess.
Okay.
I assume.
Yeah, I called Candace and had her call iTech. So, I don't know if that solved the problem. I probably didn't. It's probably just a bunch of people.
I bet a lot of people called iTech.
Yeah, I bet you we weren't the only one. I don't know if I should call Candace back. Okay. All right. So we're looking at this code right here. This is from the Writing Geometry's help, and we're gonna scrape this code and put it in our code to make it work. So the first thing that we did, while you all were gone on the coast, is that, yeah.
Oh, you have to share again.
Have to share again, that's right. All right. Should be getting that now. Are you getting that now?
Yes.
Okay. So, as you remember on the coast, everything from here up, we definitely had before the drop, right?
We had just got done typing out the print I and J. You were explaining.
Yeah. Okay. Okay. So I copied that IJ into this code here, but we'll get to that in a second. All right. So we had this. So the next line on here, because we don't have the full path, the next line is that I combine the output path and the output name to give us the feature class location. That's this line right here. This line right here. And Teresa pointed out that we could add this little slash here to help solve the problem because there's no slash in between the two. See that? So that's actually a new. The slash that's highlighted right now, you have to add in your code. Okay. And so.
The out name looks like it's missing.
I'm sorry. What?
Where you say FC equals out underscore path.
Yeah, you're right.
Shouldn't out underscore name.
Yes. Good call. All right. So we got our output path and our output name. We're combining them. The fancy word for that is concatenating them in a string. And then we copied this line directly from. You can come in and work and do whatever. Okay, they fixed it already. You can tell Miss Candace. Yeah. Thank you very much. All right, so this next line of code, cursor is just the name of a variable, and arcgis.da.insert cursor. That's the entity, the object that helps us to create a new cursor. So I'm gonna create that cursor there, and I need to feed it the path. The FC is the path to that location, and I need to feed it the names of the fields I want to modify. We're going to start off just modifying the XY, okay? But eventually we're gonna modify other fields. But right now we're just going to modify the X and the Y.
Are those square brackets on our shape file?
Yes, it's a list. What's that? Yes, X and Y needs to be a tuple. What's that? I'm creating it. I'm creating a new X and Y. And this line of code I just copied over. I'm just going to get rid of this. In fact, maybe a better way to do this would be like this. I, comma, J, and then put XY back here. So now, inside the loop, what's going to happen is the I and the J are going to become the X and the Y locations. 0, 1, 0, 2, 0, 3, 0, 4. And then the next time through it'll be 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Okay? And then it's going to insert that XY that I just created into the shape XY field. Since it's a point shape file, it'll work just fine. And then one thing that I like to do at the end, I don't think it's in the examples, is I like to delete the cursor. I think that more often releases it so that it can be used again, although I'm not sure. All right.
So is that deleting that cursor, insert cursor tool, or the cursor variable?
It's deleting the insert cursor variable that's an object in memory, and I think that it helps. Maybe I'm wrong, but I personally think that it helps keep those cannot get an exclusive schema lock on the data errors. But even with it in there, it doesn't always seem to work. But I put it in there. All right, so I'm gonna try to run this. There's an error. Okay. Try putting 2 slashes in there. See if it works. Yep, that worked. At least it got past the. Alternatively, you can put the slash in the other direction. All right. So once you get the numbers flying across your page again, and it gets to the bottom, you should be done. And if you look at it in ArcGIS, it should be there. I got SPA Lab, refresh, and it is there. And if I drag it into ArcGIS, I should get something that looks like that. Rows and columns of points. All right. So it's a quick way. You could write a tool now that allowed you to specify a min and a max, right? And your min and your max would always your min and your max would allow you to go over a range. In other words, if you substituted out this 0 and 10 value with a range and this 0 and 10 value range, you could specify anything that you want, any range that you wanted to. I can demonstrate that real quick. I'll just call this points 2 real quick. And let's do 100, 500. And then actually let's also change this to comma 10 and this to comma 5 and make this 100. So what's this going to do? What's this addition going to do? Change what? Change what about the points? So this. Remember the range variable. It goes from this value to this value, and this is actually the step. So it's going to go from 100 to 500 by 10. Let's go from 0 to 100 by 5. So what's that going to do to the points? Space them out. Exactly. More spread out. Good. Okay. So if I run this. And if I have to change that to points 2, otherwise I'm going to get that error because it's open in ArcGIS. So now I'm going to get a lot more numbers. The numbers are just going to like bzzz, all over the screen here. Bzzz. All right, I'm finished though. Oh, I should change the example. This is still calling this example 1, aren't I? Oh, I'll go back and fix that later. So I'll save this as example 2, no, 3. And then I'll fix example 1 so that it's just creating the file. Okay, so now I've got this this points 2 dot shape. And I can see that this one was from 0 to 10 to 0 to 10. This one is from 0 to 100 by 5s, and then 100 to 500 by 10s. So if I zoom in here, we should be able to see the difference in spacing, and we can. See how these are spaced 5 apart. These are spaced, 10 apart. These are spaced 5 apart. Why am I not using a unit? Why am I not reporting what units they're in? Well, if we go here, it's actually saying that they're in decimal degrees, which is not decimal degrees. You can't have 500 decimal degrees. It's ArcGIS. We didn't specify a coordinate system. And so it's just assuming, it always assumes, if you don't specify a coordinate system, it always assumes in decimal degrees. So, anyway, but technically they're not in any units. But if we wanted them to be in units, we'd have to specify a projection file or a current data set. Okay. So let's change a few things about our script. I'm going to take both of those out, and I'm going to kill points 2 and points dot shape. In fact, I'm going to hit new screen, totally new map document. The reason I'm going to do that is that when I create a data set, sorry, I don't want to do that. Okay. No, I don't want to save changes done. That's right. Okay. So I just deleted everything so that I could overwrite it. Okay, so we're going to practice a few things. I'll save this as example 4. So the first thing that I want to practice is writing a different variable out. So I'm going to put ID here. Okay. So now I've got that ID field. I'm pretty sure it was capital I, but I could be wrong. I think it was like that. It'll give me an error if that doesn't work. So what if I want to update the value ID? Where do I put that in this code? Which line of code, first of all? Is it this line, this line? If I want to also update the ID, which of these lines would that go into? It'd be under the second 4. Okay, that's right. So it's one of these 3 lines of code. If I want to change the ID, I could just put that right here. I could, whatever I want the ID value to be, I could put it in. Like if I wanted it to always be 6, then I could just add it in right there. And now it's going every time I run through, it's going to put the value 6 in the ID. Now it'll only work if ID is a numerical. If ID is text, I have to put 6 in quotes. What if I always wanted it to be the product of I and J? If I always wanted I to be if I always wanted the ID to be the product of I and J, I could just go I times J. And now that column, ID will always get the value of I times J. All right. That's just an example. Okay, now that's going to work, I think. So the next thing that I want to demonstrate is changing this so that we do use a projection file to specify a certain projection. So if we go into ArcGIS, if you go to let's forget where these are stored. Our toolboxes. Let's see, I think it might be easier on disk because it's in the program. Oh, here, let's just say star.prj. Where are all the PRJ files stored on disk? Because I don't remember off the top of my head. I should. But I'm searching in the C drive for all the PRJ files. And the PRJ files are the projection files, and they store the coordinate information like there we go. No, that's from a course. Also, most shape files actually store a projection file along with it. But I'm looking for the kind of like the master files. Let's see. If I say insert, no, I'll go like this. Right click and say properties, and under coordinate systems, it should give me the path somewhere. I don't see where the path is. Okay. I want this to be general for everybody's computer, though. So this is Mississippi Transverse Mercator, but I don't know if this is going to be on everybody's desktop. Open file location. Yeah. All right. Okay. Well, there's a PRJ file that we could use that's in the data for the class. So if you go to the website, it's in week 8 under archive, and there's this PRJ file right there, and that is the Mississippi Transverse Mercator projection. That's what that's in. So if I copy that, and let's say I put it in the same directory I've been working in, so you can put it wherever you want. So I'm going to put it right here and paste it. So now I have that file. And this is the name of the file. I could change it if I want to. It's so if you want to go to the GitHub site, if you go to week 8, you probably already downloaded this somewhere because it's the city's data. And you go to archive, and you go to this cities.zip, and you download it. I'm just trying to find a PRJ file that everybody can get. It's in there. All right, so
We're putting it, we're going to put that where we're storing our code.
yes, you can do that if you want. I put it in the same. It's more important that you just know where it is. I put it in the same place that I put the data, where I'm putting the points to data. And so that way I can add a line here that says the PRJ location equals the out path plus cities10.prj. So now it's in this location. I mean, yeah, it's in that same location. I don't have to change the path again. All right. So now I can add that PRJ information in. That's not what I meant to do. This one. No, not that one. It's the help for this. So the template goes right here, has the spatial reference. It's 1, 2, 3, 4 after that. So I got template has M has Z spatial reference. So I can just say template has M has Z spatial reference is going to be PRJ location. Make sure you spell it the same way, which I didn't do. There we go. So now it'll have that same projection as the same coordinate system as the as this data set, because I got the projection file from that data set. And the ID field should be filled out. Okay, it looks like Candace just told me it's working now. Okay, so I'm going to run this, and it's going to create a data set points to once it runs. So I refresh it. Now I've got that points to data set. If I click properties, it should have MSTM as its coordinate system, and it does. So it's got the right coordinate system. If I add it into ArcView or ArcGIS, I've got those points, and when I move around, it says down here, it says that we're in meters. So it's working. It's doing everything it's supposed to do. Oh, one more thing we need to check. Open the attribute table and make sure that the ID is the product. It looks like it is of I and J. So all those additions that we made, they work. They allowed us to write that data into that shapefile. So I'm going to hit save, and then now I'm going to change this so that instead of writing out a point shapefile, I'm going to write out a polygon shapefile. I'm going to skip line shapefile because it's the exact same thing as writing a point shapefile, except for with a polyline shapefile, all the points represent a line. In a polygon, they represent a polygon. And if we look at the help here, you'll see when we write a polygon, this is a polyline. This is a polyline again. Well, these examples shows polygons. All we need to do is change these into polygons, and it'll work. Okay. So we're going to create a polygon. This might involve a little bit of math, but we're going to use the same data set to create a rectangular polygon. Instead of creating just this one point, we're going to create a rectangular polygon that goes from here to there, to there, to there. So we need to create a polygon. Every time we create a point, instead of creating just a point, we're going to create a polygon. And it's going to be a rectangle. So the first thing I'm going to do, just because it no longer makes sense, is to change this to rects, meaning rectangles. And we're going to change this to polygon. I think it's all caps. polygon, Rex. We're still going to leave the same coordinate system. The only other thing that we have to change down here is under shape at XY. We need to change that to just shape at, because it's going to be, we need to give it the whole polygon, not just the XY location. Right? So now we need to go about building that shape. Okay. All right, so let's go back here for a second. So let's copy this array code and put it right here. We can actually get rid of this. I'll just comment this out. Okay. So we need to create a new array every time through the loop, a new polygon. And it's going to have 4 points. Right now it just has 1 point. Okay. Those points are going to be, the first one's just going to be I comma j. It's going to start at I comma j, and then it needs to go over, and then down, and then back over. So we need 4 points. To do this, I'm just going to go like this, except I'm going to create 4 of them. 1, 2, 3, 4. So I've got 4 points. One of them has ij, the other 3 are empty. They don't have anything in them. So it looks like the i's are skipping by 10. So to go over to the next I, what's another way to say that? The next I, the next possible I value, if I want to draw a line from this I to the next I, how could I express that location mathematically? Yeah, I plus 10, exactly. So I can go in here and say I plus 10, comma, and what's the j going to be of that value? It's going to be the same, okay? The y position, it's just going to be j. So now if I want to go down, I could say I plus 10, comma, j plus 5, because now I'm going to go, I've drawn over 10, and now I want to stay there but go down 5. So that's why I say I plus 10, j plus 5. Now I want to go back over, I get rid of the I plus 10, I just did I, and then say j plus 5. So now I've got all 4 of those points. Basically, all I've done is gone from this point to this point to this point to this point, mathematically, because this is ij, this is I plus 10, comma j. Oh, I'm explaining this wrong, but it is working. I'm actually in this corner, sorry. So I went from there to there to there to there, technically. Because 0, 0 is down here in this part of the world. So 0, 0 is down here. I plus 10, j plus 5, just j plus 5, same lines. All right. So now if I save this, I think I already saved this as a new example. Now I'm going to run it. And, oh, it's still not going to do anything yet though. Sorry. I only input x and y, which doesn't even exist, so it should give me an error. X, y is not defined. Good. Okay, so now I need to give it I need to create a new polygon. So points, you don't need to do this, but with polygons, you need to have this line in here that creates a new polygon. So you say polygon equals arcpy dot polyline, but I'm going to say polygon, and then you feed it the array. And then you feed the call it polygon. I'm gonna call this new polygon just so that. Oops. So now we're giving it the new polygon, and we're keeping this the same. Hopefully this runs, but who knows? Because I already ran it once and it failed. Let's see what happens. Let's see if it lets me overwrite that data set. Here, I'll pull that back up for a second. It's running. But the real test will be to see if we did in fact create a bunch of squares. So we refresh this guy, see if Rex is on there. Move it over. There's all our rectangles. One thing there's one difference between points and polygons and polylines. I said they're exactly the same except for one thing. So look at how it created those rectangles. That's what we were trying to do. The one difference is that you don't actually have to explicitly close a polygon. We just did this point, this point, this point, and this point. But if you want a polyline that follows the boundary, you have to feed it this last point to close it up. I guess that's one difference. So writing a point is easy. Writing a polygon is pretty easy. You can basically just feed it another point. A series of points. All right. Didn't work. Invalid syntax. How did anybody else having an issue on the coast? Run that. Okay, that's because you don't have an extra. Trying to see if the range. No, after that. Yeah. Working out. All right. Yeah, so you change this to new polygon. So for you spell polygon. Well, you spell polygon wrong. Just spell wrong again. And it'll be all set.
Mine is creating a new feature class, then it's just empty.
It's just empty. It didn't actually put anything in there. What's your there?
Well, actually, there's polygons in the attribute table, and then it shows up
How many records?
another 99.
Okay, that sounds like it's right.
Or sorry, 800.
It's having a problem on this one. Oh, you see, go back up. Go back, I know. That helped. So, this is still, oh, but this is points. You need to make that the rest. That's why I'm trying to update the points. Okay, Maggie, you still having the issue?
Yeah, try to run it again.
If you want to send it to me, I can look at it real quick. I've been able to debug most everybody else's. Are you addressing me? I'm sorry. What's that?
I created two polygons and then I can add.
So you say you found out what you did?
Yes.
Okay. All right. So oh, I see. I see your problem, Maggie. This needs to be changed from X to XY to just not XY. That's probably what it is. I'll go ahead and run it and make sure. But oh, yeah. Did that fix it? Let me know if that fixed it, because I have to change all the paths to get it to work. But did that not fix it?
It's not done yet. Even though I have the override that's the true, whatever, I just put it over.
Actually, I can change the path real quick.
Okay, it worked.
Okay. Okay, great. All right, and the reason that didn't work is because shape at XY is just changing the point, not the whole geometry object. All right, so like if we add, so for the lab today, you're going to read in a series of points, and then you're going to make those points into a polyline. You're going to take it represents a track. So the GPS. I'll go ahead and explain. So they're animals with GPS collars, and every so often, every second or two, you get a GPS location. So the GPS location is what you want to plot on the thing. So if you're going to do polyline, so every line you need to add to the every point you need to add to the polyline, and then every time you finish with that animal, you're going to have to switch on to the next animal and save that one out. All right. Okay, so let's practice a few more things before we take our break. I know we're running a little bit late, but we had that interruption. We usually take our break somewhere between 2:40 and 3 o'clock, which will probably be about 4 o'clock. I want to practice a few more things. One thing is that I want to demonstrate that these geometries have since they're geometries, they have the ability to be changed using the methods that are published by ArcGIS. So the first one I want to do is that's in the help that we were just looking at so that's here. So if I go to polygon geometry, for example, I can do something like buffer those polygons before I even write them out onto disk. Okay, so here I've got the polygons, and I can, where's buffer? I can buffer a polygon with a distance. So down here, I could say that my new polygon, instead of being just a polygon that's an array, I could also buffer it by one unit, by 1 meter. I'm going to call this Rex 3 and save this as example 6. So now I'm taking that polygon, creating it, but then I'm further buffering it by 1 meter. And then I run that guy. And when I have all the outputs, they'll look a little bit different. They'll look a little weird. Taking a long time. All right, well, not quite done. So the buffer is actually what's taking the extra time. See how much longer it's taking? I'm buffering every single polygon by 1 meter. And maybe I should have buffered them by more just to see what it would look like. Okay, finished. So now when I look here, go to Rex 3. Oh, I skipped Rex 2, I guess. If I move this up to the top, Rex 3. Actually, I put the points on the top. But you can see, if we zoom in here, that it's buffered out a meter from the edge. Actually, maybe I should put this one on top. So this polygon is a meter out. You can't see it because it's below this the polygon. So if I select, see if I just select this guy right there. See, it's hard to see on there, isn't it? But this is selected and it's buffered out a meter past that thing. All right. Another thing that I could do is, let's just say that I wanted to get just the difference between those two polygons. So I've got my new polygon 1 and my new polygon, which is a buffer. So I only want the piece that's outside of the buffer. Then I could say new polygon dot difference new polygon 1. Let's see if that's in there. Difference. Yep, it's there. And then I'm going to get a new polygon. This because this says that it returns a new polygon. So output polygon is equal to the difference between those other two polygons. And I'm going to save that polygon to be the output. Let's save this as example 7. This is going to take even longer to run because we're doing two processes. We're taking the original array, we're buffering that same array, then we're finding the difference. So it's just the outside of those two polygons. Oh, it already exists, so I'll call this Rec 4 and run it. all done. I can add Rex 4 in there. And then now I definitely will have to close up the other stuff to see what it looks like. You can see that the polygons are now just the leftover, the stuff that was buffered, but it doesn't include the inside of the buffer. So if you ever had a spatial analysis that depended on finding only those areas that are outside but close to an object, you could write a custom tool to find all those areas. Of course, you could conceivably do this outside. Okay, one more example. We'll call this Rex holes. So what we're going to do here is we're going to put. Let's see if anybody can think about logically how you do this. I'm going to go back to creating the original rectangle. But instead of creating the original rectangle, I want to put a 2-meter hole in the middle of the original rectangle. Just in the very, very center. Logically, how might I do that? Not in code yet, but how could I do that? Remember, what's that? Remember that we've got all of these methods on here. One of them is actually the centroid. So we can find the centroid of a polygon. So I can go back to my 2 data sets here and say here's the new polygon one, which is the array. Instead of doing this, I can say centroid dot buffer 2. That's all I had to do to change that. Now this will do exactly what I was saying. So it's going to create a new polygon. Then it's going to take that same polygon, find the centroid, buffer the centroid by 2 meters, and then it's going to find the difference. So it's going to find only those areas that are not shared in common by the 2 data sets, which is going to be the outside. It's going to punch a hole in the center that's going to be a circle. And then it's going to run it. So if I run this guy, I'm going to get a punched out circle in every single polygon shape. And this is useful in analyses where usually it's like, usually you're looking at a circle punched out of a circle. It's called an annulus. Sometimes it's a donut shape. So if you want to do an analysis of the surrounding area that doesn't include the area, oh, so point has no buffer. Can't buffer a point? What? I thought you could buffer a point. Point. Oh, I remember. You actually need to create a point geometry object with the point, and you can buffer the point geometry object. Okay, so something like this. Sorry, code was a little bit off. So instead of getting just the centroid, we do need another step in here. We need to say, just like this, arcpy dot point geometry, we need to feed it the point, then we can buffer that point. We could do these on different lines. Like you could create the point, see this line right here? You could create that point and then put it in there and then buffer it. That's going to work. So this could be its own line, but this is an example of composition back, looking back at the Python book. This is putting, like, really, you could break that into 3 lines if you wanted to. You could do the buffer in one line. You could do the, well, from first to last, you could do the centroid in one line, save that as a variable, then create the polygon, the point geometry in another variable, and then finally buffer that point geometry to create the polygon as a third variable. So the way that this looks is like this. Mine didn't work out the way I thought. Did yours have holes in it? Yeah. Mine should. Like holes right in the middle. Just circles. Not the, okay, so it's not punched out circles. What about yours? Oh, they're just circles. What's that? Turn off the rack. Mine aren't nothing. Oh yeah, I'll leave it up. And yours runs down. Yep. Interesting. Well, I don't know what my problem is. Oh, output polygon. Oh, that's... Teresa, did you do did you code anything that's a little bit different, or? You don't think so? So somebody's code worked out. But this is still like that? That actually might have mattered, because the difference. Yeah, try it out. Refresh. I'm still not getting anything. Polygon 1, buffer, arcpy. I don't know why I'm not getting anything. You're not getting anything now? Now you're not getting anything. Well, I don't know exactly why that's not working, but we're getting like, into a more specific example here, but anybody else who's getting circles at least? Okay, so we got kind of got circles. Yeah. Oh, so you'd still add new polygon here? You have nothing. What do you have there, Teresa? Right there where that's highlighted. Output polygon? What do you have right there that I have highlighted? Same? Yeah, I mean, I think it should work, but Teresa's works and mine doesn't. And I have no idea why. So I can look at on my other computer during the break, but this should work, and it's working on somebody's computer, but it's not working on my computer to create that. Did yours work if you did that? I don't know why that would work. Yeah. And I guess I could do new polygon or polygon dot centroid, buffer it. What about this, Teresa? Are these different? This new polygon, does it say new polygon 1 or new polygon? Okay. All right, I'm going to try running this one more time, and if it doesn't work, then we'll just take our break and then work on the lab. All I changed was this to new polygon instead of recreating that polygon twice. Okay, that finished. I wonder if I needed to like press refresh over here, if that matters. I got something. Yeah, that's right. I don't know why that solved the problem. I wonder if it was just because I wonder if the thing all along was just the new polygons were different on mine versus Teresa's. And I just never hit refresh to get the newest layer. Because all this was doing was forcing it to take this. But, yeah. In any case, it works now. Right, so that's that. All right. How about on the coast? Did you guys get it circles at all at any point?
I did.
Now you're getting errors. Maybe because you have files already open. What I'm going to do here, you're not getting circles. Are you still getting squares? Did you try refreshing? All right, what I'm going to do is during the break, I'll upload this example so you can see it.